Hello everyone, welcome to my topic Circuits and Networks. I am Ravikant Malla Joshua and today we are going to discuss with Reciprocity Theorem. Reciprocity Theorem, it's a small application theorem which is defined as the ratio of response to excitation is invariant to an interchange of the positions of the input, that is what we call as excitation, and response in a single source network. So how do we understand by this particular statement about reciprocity theorem? In order to understand this, let us go with an example. For example 1, we have to find response of current in 6 ohms and check whether the circuit satisfies the reciprocity theorem. Here it is a simple network. You can see 15 volts is the voltage source and it's a passive network since you have all the resistors, and we need to find out the value of current in 6 ohms. We need to find out the value of current in 6 ohms using reciprocity theorem, and this can be done using mesh analysis, node analysis, or by current division or voltage division rule. So how we solve this network using mesh analysis, node analysis, current division rule or voltage division rule? It's depending upon your interest to select the method. I'm selecting here the current division rule as well as the mesh analysis. You can see here 8 ohms, it is in series with 6 ohms, so therefore it becomes as 14 ohms, and that is in parallel with 12. So this combination will give you the answer as 6.46 ohms. Now this 6.46 ohms is the reduced value of the resistor of these two parallel circuits. Therefore, the circuit looks like this. When the circuit looks like this, you can see 4 ohms is in series with 6.46 ohms. Now you can calculate the total current in the circuit with the help of mesh analysis, which will give you the value as 15 by 10.46, which is equal to 1.43 amperes. Now this 1.43 amperes is the value of total current over here, and the same value of current is flowing over here. Now this current is flowing over here, so you have parallel resistors. So with the help of parallel resistor are there, therefore with the help of current division rule you can find out the value of current in 6 ohms. So from current division rule you can see we can obtain the value of current in 6 ohms as I total, that is the input current which we are obtaining, and place parallel to 12 ohms, which is parallel to 8 in series with 6 ohms, whole divided by the sum of the parallel resistors. So 12 plus 8 plus 6. This will give you the answer as 0.66 amperes. Now we have find it the complete solution, that is we have estimated the value of current in 6 ohms, which is 0.66 amperes, and this we have done with the help of current division rule and simple KVL analysis. Now we have to interchange the positions of the excitation and the load. Now 15 volts, it is excited over here. Now this can be removed from this particular point and it can be placed in series with 6 ohms. Why in series with 6 ohms? Because we have to interchange the positions and we have to find out with the help of reciprocity theorem. So you can see here what I have done. I have just taken 15 volts voltage source like this, and I'm going to place over here and have to find out the response from where it was initiated. Initiated means it has been removed from the first point where it was given as the excitation. So we are placing the 15 volts in the load where we have calculated, and just we are finding out the response in the place where we have placed 15 volts. So from this network, you can see 4 and 12 are in parallel, which will give you the answer as 3 ohms. So you can replace this particular circuit with this simpler circuit, and you can find out the total current in this particular circuit. So the total current would be 15 divided by 8 plus 6 plus 3, that is 17, which will give you the answer as 0.88 amperes. Now 0.88 amperes is the total current over here. So this current is nothing but this current which is exactly given from the main circuit. Now from the current division rule I can find out the value of current in 4 ohms, like I is equal to I total, that is the input current, and the opposite resistance. For 4, 12 is the opposite resistance divided by sum of the parallel resistors. So 12 plus 4, which will give you the answer as 0.66 amperes. And hence, with these two approaches, the reciprocity theorem is verified. Let us go with another example. Now this is a typical example where you have to find out the circuit to be reciprocal, as well as we need to find out the value of voltage and power developed in 5 ohms. Now here we need to calculate the value of voltage and power using reciprocity theorem. We have to verify and we have to find out the values. So what we are going to do? We are going to take the help of mesh analysis, and I am taking here the loop analysis or mesh analysis. I am identifying the loop currents I1, I2, I3. From I1, I2, I3, I can easily estimate the value of voltage, that is voltage developed across 5 ohms in this fashion. So the voltage developed will be nothing but a resistance multiplied with the difference of the currents. So I2 difference I3, in fact I2 minus I3 multiplied with 5 will give you the value of voltage across 5 ohms, and later on you can either use the current or voltage values to find out the power developed in 5 ohms. Is this clear? I think this is simple. Now the given circuit and the directions of the current, and from the clear inspection you can see the direction of the current I1 or the loop current I1, it is equivalent to 10 amperes. Now these two values will give you the rest of the results. That is, we are going to apply KVL in loop 2, and later we are going to apply KVL in loop 3, and then we'll estimate the value of current I2 and I3, and we'll find out the difference of the current which is flowing in 5 ohms, thereby estimating the value of voltage and finally finding the value of power. So we are applying the KVL in mesh 2. You can see here we are starting from 2 to I2. This is the developed voltage. Then plus 5. This is this I2 minus I3 plus 4 over here. I2 minus I1 is equal to 0. So satisfying the Kirchhoff's voltage law will give you the equation as minus 4I1 plus 11I2 minus 5I3 is equal to 0. Now this is one equation. On the similar basis, we are applying KVL to loop 3, that is this loop. And I am starting with 5 I3 minus I2, that is overdrop over here, plus 8I3 plus 6 I3 minus I1 equal to 0. This equation will give you the value to be minus 6 I1 minus 5 I2 plus 19 I3 is equal to 0. So equations 1, 2, 3 are framed. Therefore, substituting the value of equation 1 in equation 2 and 3, I am going to obtain the values for I2 and I3. I'm rearranging the equations of 2 and 3 by substituting equation 1 in 2 and 3. So these are the two equations to be solved. With this, I got the value of I2 as 5.76 amperes and I3 as 4.67 amperes. Now I want to obtain the difference of the current in 5 ohms. So I2 minus I3 is equal to 5.76 minus 4.67 will give you the value as 1.09 amperes. So once I am obtaining the value of current, that is a branch current in 5 ohms, I can easily obtain the value of voltage, which is equal to current into resistance. So this value I'm getting as 5.42 volts. I'm making this value as equation 5, and also we need to calculate the value of power. So power can be estimated with the help of I square R or V square by R. So either I can use 5.42 square divided by 5, or I can use 1.09 square 5. So it will give you the value of power developed in 5 ohms. So the power developed in 5 ohms, I am taking the help of current, that is I2 minus I3 whole square into 5. So this value will give you the answer as 5.94 watts. Now you can see with the help of mesh analysis, we have solved the given circuit and obtained the value of voltage as well as power. Similarly, you can obtain the values by interchanging the source position. So you can see now, this is the reciprocal circuit of the given circuit. In the previous circuit, you have 10 amperes, it was driving this entire passive network. Now this 10 amperes has to be placed parallel to 5 ohms because it's a current source. That's why we have to pay parallel to the current source. And since the current is traveling in this direction, I2 and I3 are in this direction. So positive and negative voltage would have been developed across 5 ohms in this fashion. So therefore, the value of current source can be replaced over this particular point in this fashion. Clear? Now, after interchanging the sources, we need to find out the response, output response. So voltage will be the response. In the previous case, current is the source and voltage we have estimated as 5.42 over here. Now we are going to change the position of the source current, which is parallel to 5 ohms, and we do need to obtain the value of voltage across this particular terminal. Since it's a current source, that's why we have open circuited. If at all it would have been a voltage source, then we would have short circuited this particular point. Since it was a current source, we have open circuited it. Now we can estimate the value of voltage over here. Now this voltage should be equivalent to 5.42. So how we are going to solve this? Now you can see what we have done here. This 5 ohms, which is in parallel with 10 amperes, is changed to 5 ohms in series with 50 volts with the help of source transformation. The source transformation can be taken as V is equal to IR. So with that, I is 10, V, resistance is 5, therefore V equal to IR. 5 into 10 will give you the value as 50 volts in series with 5 ohms. Now this is the reduced network of the given network. Now we have to find out the voltage over this particular point and we have to make sure that it is obtaining as 5.42. So what am I going to do? I'm again taking the loop currents as I1 and I2. These two currents are different from the previous two currents. So applying KVL to the loop 1. So I'm going to get as 4 I1, since it's open circuit, that's why it's 4 I1 plus 2 I1 plus 5 I1 minus I2 plus 50. On the path, I'm getting the value of voltage as 50. That's why I'm taking the positive 50 equal to 0, which will give you the equation as 11 I1 minus 5 I3. No, it should not be I3, it should be I2. Sorry for the mistake. It should be minus 5 I2 is equal to minus 50. So this is an equation 7 and applying KVL in loop 2. So applying KVL in loop 2, then we are going to get 8 I2 plus 6 I2. Since it's open circuit, you don't have any current over here. 6 I2. On the path, I'm taking the value as minus 50 plus 5 I2 minus I1 equal to 0. So rearranging this equation, I'm getting as minus 5 I1 plus 19 I2 is equal to 50. Please make sure, friends, that this is not minus 5 I3. It should be minus 5 I2. Okay, so solving equation 7 and 8, I'm going to get the value of I1, which is equal to minus 3.8 amperes, and I2, which is equal to 1.63 amperes. With this, I'm going to apply a new KVL to this open circuit conditions. Since it's open circuit, I can have a measurement of voltage over V, and I can find the voltage equation by applying KVL, and the currents which have traveled across 4 ohms and 6 ohms would have developed the voltage in this fashion. Then applying KVL, that is minus, it is starting from this, so minus V minus 4 I1 minus 6 I2 equal to 0, which we are going to substitute the values of I1 I2 in this equation. So I'm going to get the value of V, which is equal to 5.42 volts. Now as you can see, the result what we have obtained using this transformation from source point to the response point, that is excitation to the response, is same as the same response what we have obtained using the given original circuit. So this is how we have satisfied the reciprocity theorem. Already we have calculated the voltage and we have estimated the power. You can get the value of power, which is approximately 5.94 watts. So this is how we solve this kind of particular circuits using reciprocity theorem. So today's class we have seen the example of reciprocity theorem. If you like my video, share among your friends, subscribe to my channel, and please press the bell icon for the future notifications.